All
right. Hello, everyone, and welcome, and thanks for joining us today. You got the screen?
Yeah, I'm just getting it sorted out for you.
There we go.
Lovely.
All right. So we are going to be talking about how to rethink the full database refresh and how to create small, secure, accurate development database on demand. So we'll be hearing from Hugh Price, Chairman and Co-founder of Curiosity Software, and Harry Byrne, who is Head of Solution Engineering. They'll walk us through the current state of environment management, where traditional approaches start to break down, and some practical ways to reduce your data footprint without losing accuracy or control. If you've got any questions as we go, feel free to drop them in the chat and we'll pick them up towards the end. So
just talk through the housekeeping a little bit.
Absolutely. So basically with the housekeeping, we've got a couple of different options. We're going to have some polls appearing throughout the call, so feel free to interact with those. We're going to have a Q&A section, the public chat, basically, you can just put any questions in there and everyone can see it. Or if you have something a bit more personal to yourself and your company, please put it in the private chat and one of us will get back to you.
Okay, cool. Okay, so you can hear me okay? No problem? Good. Okie doke. Right. Hello, everyone. So today we're going to be talking about the wonderful world of provisioning environments for developers, testers, trainers, outsourcers, all sorts of people that really need to get out some kind of environment to. Do you want to just mute out there? I can hear. Great, thanks. Now, for those of you who've been to some of our webinars before, we've tended to focus on various different components with kind of approach and also our kind of modular software that we have. But today it's kind of a little bit of everything. There's all sorts of stuff going on when it comes to environment managing. So I just thought I'd leave this up here. So a fair bit of subsetting, a fair bit of cloning, integrated data, federated data, synthetic data, and all those very different things, and a lot to do with data pipelines, which is stringing together the various components that you're going to need to assemble environments that are effective and cost effective and efficient. So let's just move on a little bit. So I'm going to talk a little bit first about the current state of environment management, the current state of data masking, which has been around for a long time, the tools and technologies that can help you, and best practices that can help in terms of how you can make significant improvements across your enterprise. As well as this, we'll come up with a set of tactics to help you sort of reduce your data footprint and improve quality, and in effect save money, really, in terms of delivering systems faster, quicker, better. So I'm not sure if we've got any polls yet. Maybe we'll have a look at those at the end instead, Sophia. So we'll just skip over that for the moment. So let's just look. Now, I've been in this game for way too long. Over close to 40 years, I've been dealing with data in various different systems, and we talk to lots and lots of large and work with lots of large enterprises. And I would still say the most common method that people have is to copy full-size data out of their production environments into their development environments in some way, shape, or form. Now, so typically the process as it works is you'll have your production environment. It will get moved into a secure staging environment, and then there will be some degree of masking within that. The movement, sometimes people use disaster recoveries or sort of quick flash rollback mechanisms to be able to do that. And then once that's masked, that is then moved off, again using various different methodologies to get the actual database moved into another environment. And of course, this is happening for multiple of your databases, and your data stores are all kind of being moved over. They're being masked, and of course, it doesn't all happen in one go. It all happens, spread out over several days, months. So they're generally out of sync. Now, The first problem, which is very practical problem, and as a developer, I always remember this, working back on Wall Street back in the 80s, whenever they copied the full-size production data over into the development environment, we would pretty much lose all of the data that the developers had set up to work with, on the current. I guess it was a release rather than a sprint back in those days, and that was highly problematic in terms of having maybe to spend a day or two actually resetting up the data for the particular set of development scenarios that you're working on and building. So that's one problem. The other issue, of course, is that you know that all these systems interact and are out of sync. If we have time at the end, I'll talk about some techniques to be able to kind of help with that particular problem, which is obviously a fairly substantial problem. So they're generally, they're out of sync in effect, and it's pretty tricky. You'll often, try and run a transaction through it will fail because uh, a cost code or a payment schedule or a particular broker isn't available, or they're in a different state, or they have a different balance or something like that, and that will then cause that to fail, and you spend ages trying to work out if it's a software issue, or you try and work out if it if it's an actual um, and it generally is a data issue. This is especially true of automation. One of the most common reasons that automation fails is actually the data and not the actual code itself. So copying full to low environments, is highly problematic. There's so many issues with it. Um, you do masking, and I'll talk in detail a little bit later about the problems with masking. It's kind of a bad idea to mask the data. Uh, Information can leak out through development, and there's this idea of PII data, personally identifiable data, but then there's commercial data, and no matter what you do with masking, there are techniques, uh, specifically to machine learning, where you can kind of move away from that. That development environment does contain lots of oodles and noodles of really interesting um, commercial data, sales plans, salaries, um, how your new product is being launched, and all of these things are actually of interest to your competitors, and really you don't kind of want them to be sloshing around, and a lot of it, once the data is masked, it's used by outsourcers. um, uh, Often it's not in the country where the company is domiciled, so that may well then be actually leaving the country as well, even though it has in theory been masked. you know Sending out mass data again is really less risky. Quite often you want to go outsource some development, so you might set up a specific database to be able to do that, and the trouble with that is that the commercial data sitting within that is problematic. So there are lots and lots of risks with masking, and we'll talk about some of the bad standards that exist in masking. The other thing with masking is you need to ensure that the other systems use the same masking algorithms. I showed three systems. Three systems is kind of optimistic. I think for large organizations, you're probably talking in the 500 to 1,000 systems in terms of all the different applications that people have got. And it's pretty common for something like a trade as it moves its way across, through the GL, through the reconciliation processes, through the currency conversion processes, through the credit rating, that you may well end up with sort of 30 different touch points to get to the final processed answer. And the problem there is if you've masked social security numbers, addresses, names, and any kind of account numbers or IBAN numbers, things like that, those don't match. So you've really got to use the same masking algorithms. The thing with same masking algorithms, you've got lots of different technologies to deal with. You've got mainframes, you've got SAP, you've got lots of ERP systems, and trying to actually get the masking to actually work. So that the same value has been masked to the same masked value, so that they do match. That takes some effort. As I said before, it destroys all the lovely test case data created by the devs and QA, and that just clobbers it when you copy it over. Um, you know, and another thing is that automation scripts we have a product which is basically a data find tool where you actually link the automation script to the type of data you want. But if you look at a lot of automation scripts, they'll have a specific account numbers in there, or some kind of hard-coded value. And the reality is, once you copy your production data in, that account number may have changed. The or the we had a good one with an HR system where all of the test cases referred to a manager who was authorized to make changes, and that manager left, and of course they were no longer authorized, and pretty much all of the automation tests changed. So these are the sort of practical issues you have to deal with, and as I said, automation scripts usually fail after a refresh. So suddenly you've done your refresh, you spend 3 or 4 days setting your data up again, and you've then got to go through and find out what's gone wrong with all of your automation scripts. Now, this is probably the big one. It usually takes so long to get the data from prod, it's already out of date. So, we're looking at one company is about 4 months to get the data over. Typically, some people will take about 3 weeks. Minimum for the terabytes and terabytes of data for multiple systems, it's probably about 3 or 4 days really to get a full system copied over and masked and out there. And for point of sale systems, anything to do with any kind of date processing, that data is now out of date. You've also got a big gap. You've got 4 days when nothing happened in your data, so that's not really very realistic. So those are kind of the sort of almost like macro problems, and then there's various practical problems. You need to coordinate the multiple systems to make sure the dates match. So if you if you pull one over 3 days later, then you've definitely got a date issue. I was working with an Australian company, and they had a team of about 8 people, and what they were doing was tidying up the ragged edges between the systems, because a lot of the integration points were failing, so they were having to construct fake synthetic data on top of the ragged edges where things didn't join up. Otherwise, none of their batch processes ran, and that was their full-time job. They had like about a good team between 4 and 8 people doing that. you know, coordinating multiple systems is tricky. Dates matches, they never will. Unpredictable bugs occur during integration testing, as I mentioned. You need to create processes to reconcile, repair, and remove unraveled data. The other kind of issue that people tend to forget about as well is that when you drop terabytes and terabytes of data onto development machines, your queries, which may run in sort of nanoseconds upon production machines with lots of memory, etc., can take 5, 10, 15, 20 minutes. Now, if you're a developer and you're trying to just run sort of fairly standard queries to even get to a point, you've really got, that can really slow you down when you're dealing with these very, very large databases as well. Often as well, once you refresh the data, there will be ancillary processes that need to run. And those ancillary processes, think of them as ETL processes. They do reconciliation. They will pass data from one system to the other. And if you have actual full-size databases and you're running that on much sort of reduced kit, then those ETL processes actually take ages and ages to run. They might run sort of in a couple of hours on the production system. It might take 8-10 hours to run those, because it's got to plow through so much data on some fairly weak tin. The other thing is regression testing is actually extremely difficult. You've kind of moved over your whole production database. Having this idea of kind of a sort of roll back, roll forward kind of database gives you this ability to do regression testing in a much more structured and organized way. So in other words, in Git terms, you'd create a branch, you can put that branch off, you would then test against that branch, and then you could just, once you're happy with it, you could then bring that branch back in, etc. So that is a kind of very, very real problem. And it's a lot of the stuff that we talk about is people have worked this way for so long, they can't really imagine working in any other way. But if you said to them, oh, if we could create you a regression copy, of your data, and you could just restore it whenever you want and restart your tests, automation, and etc., rather than you having to write SQL scripts or start again or find a different account. They go, oh yeah, I'd love that. But if you don't know about it, they ain't gonna. It's never going to be there. No one's really got a sort of a demand for it. So let's just talk a little bit about, there's a sort of common misconception that this really is the only way to work. It sort of comes back to a little bit of, um, frankly, laziness in that, oh, well, if it's not production data, it's no good. They don't really think about it. You're actually testing when you're developing and testing. You're testing a piece of functionality, and that piece of functionality has a set of data. It has a transform and it has an output. That's what you're developing against. You're not testing against, the whole concept of production data. Other people are a bit lazy in that they're familiar with certain customers or certain processes that they run through, and they just kind of use them. So there's a sort of common misconception that it's the only way to work. And it's sort of grown up over time, and I would strongly suggest that it's a lot to do with senior management, in some of these companies really aren't that technical. I think back in the day when you joined someone like Oracle, every single person went on the kind of SQL Plus training course. They spent, and it didn't really matter whether you're in a marketing team or anything. You had to actually understand and learn the core Oracle technology to be able to work at that company at that stage. I have no idea what happens now. But the advantage of that is the people grew up with a sort of a good understanding of the technology and the types of things that were available. Now, in addition to that, things have changed in that everything has been kind of outsourced and, under the guise of cost. Um, and, it's all very sort of siloed. So you've got DBA teams, you've got security teams, you've got environment teams, you've got the hardware teams, you've got the purchasing teams who pay for it all, you've got your development teams, and within the development teams, you've got projects teams and sprint teams, all of which have kind of their own budget. The QA team or a quality team may well be not related to any of them at all. I thought of as something that just kind of comes in at the end. So all of these have become isolated from each other. So it's very difficult to kind of pull something together to actually make a substantial change in the way that organizations work. You know, and I think I have come across this so many times in trying to, a good example of this is I remember arguing, should we say, quite vociferously with a security person who was horrified that we're going to install some data into production which is going to mask their data. And they'd done a scan on it, and it used a library which wasn't used in the software, which had a security hole in it. And they basically were saying, well, we can't allow this at all to go into the production environment. My description of him is, I said, look, you're basically arguing about the gate and the lock on the gate and whether it's got 20 tumblers or 21 tumblers. Meanwhile, if you look at your field, you don't have a fence around it because all of your data is just pouring out into your development environments and being shipped out to your suppliers. So the lack of perspective was very difficult for them to get because they just live in their own little world. And they just go, oh, we got a flag, red flag, got to do something, this is it. So trying to this outsourcing and silos really does mean that it's very difficult to make change to environments. The other problem, of course, are budgets are in silos. It's very difficult to pull together a budget to actually change the way that organizations operate. Another actually practical effect is working remotely means it's very difficult to brainstorm. It's pretty rare for us to actually go out and meet a whole team at the moment. Everyone would be, oh, they come in on a Thursday, or we get together once a month, things like that. So it's very difficult, and people watching meetings, or you don't really have that kind of body language, that ability to nudge people to make contributions by saying that they may be a bit nervous and they just to speak up and things like that. So it is extremely difficult to actually have a proper brainstorming session to actually think of different ways to improve your organization's delivery of environments. The other one is just the relentless pace of the joys of agile. You're getting through the sprint, how many sprint points, all that kind of stuff. I'm just going to have a drink here. Now, the reality is that I think There was a German company I worked with, insurance company, and they spent about 5% of their budget on uh, of the entire IT budget in terms of people within the development environment was spent on improving the development process. Whether that was documentation, whether that was communication, whether it was training, whether it was creating software to auto validate, etc. So having about 5% of the team's time should be spent on making themselves more efficient. Now, trying to retrospectively go back and get that out of everyone's budget is it's almost impossible. So but I think as a reasonable rule of thumb, that's you think about the advantages of that spread out over time. The improvements in terms of making your team at a minimum 10 to 20% more efficient by applying clever technologies, clever thinking, and adapting to change as things move forward. The net of this approach, it's kind of a very expensive way to run an IT department. It's the amount of tin, the movement, the sluggishness, the inability to um, fix bugs quickly, the inability to recreate bugs in development. It's kind of a lot of grit in the machine to be able to actually develop and test and release quickly. Now, that's kind of the bad news. But the other thing is that if you actually start having a look around, there are just so many. I'll just bring them all down. You can read some of them as I talk. There's so much clever stuff out there. If you look at, we were talking to one company, and they've got terabytes in their databases. But actually, if you had a look at if you had a deep look at the tables sitting in there, um, lots and lots of the tables you could just lose them. They were kind of intermediary tables. They were old table with things like underscore archive in there. They had all sorts of things in there which really weren't core to the 99% of the actual processing. Then within that subcategory, if you look at a lot of the tables, they contain dates. And if you partition by dates, even if you partition by year, um, and you apply partitioning to tables, when you move from production to development, you don't move, you only move some of the tables, and for some of the tables, you don't move all of the data. You could just use partitioning. Why not? So you end up moving maybe, I don't know, 20% of the data that you have, and suddenly that 21 days comes down to 4 days, or your 4 days comes down to 1 days. So there's all sorts of things that can go that can be used. This database rollback. Most databases now have this ability to kind of snapshot and roll back, which is quite useful, very useful if you're trying to do regression testing. There's lots of database virtualization tools out there. Some are cheap and some are just crazily expensive for what you get, kind of mad expensive. And also a lot of the databases themselves. And as you move to the cloud, where databases tend to be it's more about storage units and things like that, storage containers. It's a lot easier to kind of actually think about database virtualization. Database virtualization allows you to take large copies of data and create small images, and have as many of them as you like. The other one, message virtualization, that's basically things like I guess it was kind of like the CA Lisa products, the Parasoft products, things like that, WireMock. And those are very, very useful when it comes to integration testing. Message-based replication. So, a lot of transactions that move around from one environment to another might be stuck on Kafka queues. Now, those, or MQ queues, those queues can actually be used to apply data directly from production. You basically run those messages through masking. You don't take all the messages, you can subset them, and you can apply those down into development environments. So you're not actually thinking of it as almost like real time kind of subsetting and masking as the data comes through. Replication, AI-driven synthetic data now. I think if you've seen some of our other webinars, it's pretty easy to be able to build out the engines to build this synthetic data based on some existing data and tweaking it, etc. Machine learning synthetic data, that has we will be doing a separate webinar on this. This is extremely powerful in terms of being able to create lots and lots of data with very similar characteristics to production data, but it's not production data. Okay, so there's lots of really clever stuff out there. Now I'm going to talk a little bit about masking. As I said, there's lots of different rules around there. If you pick the EU GDPR legislation, that's probably the safest one. Everything else tends to be a bit of a subset of that. Um, like if you in the US, they have a less stringent regulation, except for California, which is very similar to the GDPR. So there's all this stuff in terms of the type of masking that's going on. Now, most people don't read that, read the regulations. They kind of sort of semi-interpret it and kind of hope for the best. So if you actually read it, it's pretty robust. For example, it says that you should be using the minimum amount of data. There is no reason to be fully taking full copies. So you're actually in breach of GDPR if you're actually using full copies, etc. So first of all, you do need to do that, and it's kind of interesting when you talk to security teams. They don't seem to really understand this. They're very, very, very focused on the production data and how leaking out and all the different things like that. But when it comes to this massive dump of data out of their organization into a different part of the organization, there's not usually the same level of attention, and they certainly don't show up at meetings with any kind of knowledge about it. As I said, you've got lots of data that give advantage to your competitors. We did a project back in the day, which was to do with land valuations, property valuations, commercial property valuations. Now, the problem with that is that you have an amount, and it's very easy a specific amount for the valuation. It was very easy to work out by going onto the live database, which is publicly available, type in amount and find out the property that you were in theory working with. So what we had to do there is we had to change the amounts, which of course messed up a lot of the summaries and things like that. So there's lots of things to worry about. Data that can cause embarrassment in the public domain. Um, you know, uh, what's PI, what's commercially sensitive, and I don't think people actually spend a lot of time really going through that. And um, one of the key things is you've got to think about how much reasonable effort would be required to identify a person from that information. And that really comes down to, if you have two pieces of information, even if the data's been masked, can you find your way back to that person or that account or to that transaction, etc. And that's a different way to think about it. So mostly when you talk about the masking that's going on, it's very cursory. It's tedious, boring. It throws up all sorts of issues with data quality, and actually trying to pull that all together into something that is um, a systematic, structured process doesn't really exist, I would say. It's very much just a project which people try and get through as quickly as possible until someone says, yeah, that's good enough, and just they move on. Um, the other thing is that sensitive data can be the most complex to obfuscate in terms of, if you've got information, HR or health information, it's extremely difficult to take historical data and, sort of mask that data out so that you can't, as I said, with one or two pieces of information, work your way back. The other thing is data has changed over time. And do you go back, and the data which was held differently and had different codes and different all sorts of information back in the day is still in the system in your very large copy of the data. And the problem with that is you suddenly have opened up a data archaeology problem, in terms of you've got to go back in and actually try and understand what's the data, what those values were meant back in the day. And all of this builds up into the complexity to kind of get involved with that masking. Now, I sort of talked about this idea of one or two pieces of information. There is actually some mathematics around it, which is called kind of the K-anonymity or diversity or T-closeness. And basically what we're saying here, if you Google this or your AI, you'll find all sorts of examples about this. But basically, there's just a small amount of information which can make your way through to. So if you have a zip code and your neighbor has heart disease, you could very easily work your way out that in that zip code who that person is, even though you changed their name and their account numbers, etc. So there's all sorts of different ways to do that, and without an understanding of this, and without people actually kind of signing off on this, then you have to acknowledge that the masking has failed in terms of its core remit, which is to protect the innocent and protect the organization from commercial embarrassment or loss. Now, there's sensitivity versus complexity. I've just thrown this graph in quickly. You end up with high complexity, and what we're saying, it becomes very, very expensive then to actually do the masking associated with it. So, you know, you plowing through all the various different logs that are created as well to make sure that those have been masked, because they're just straight cuts of what people have entered and that they've gone off into log files, etc. All of that information is very difficult, and you start to think, well, is it really worth it? The amount of effort we're going to have to go to do that. This project has now been running for 6 months, and we're only down in the bottom left hand corner here in terms of the masking that we want to go ahead. So let's just kind of think with current problems. It is poor. It's the least amount of masking that people can get away with. Security teams rarely engage in a meaningful way. Getting cross-team agreement is rarely done. And this kind of boils down to who is the data owner and who will be fined. Now, a good way we've done this in the past is to get people to actually sign off that this is the data that's to be masked. And no one wants to do it because, organizations and individuals can be fined with the regulation. So if you sign it, you're saying, right, I have done due diligence, I've taken it through all the way, I've got all the audits. So you are the data owner, etc. So it sort of lives in this gray area where people sort of hope that doesn't happen, and it just sort of happens. It's sort of left to the technicians to come up with something that works, and then they say, yeah, that's okay. But the problem is sitting there. Who is the owner? Who owns that data, and who has masked it, and who has confirmed that this data has been masked and it is masked to a sufficient degree? The other one, quite often you'll have quite simple masking. Names change to X and Y's, and it actually makes it quite difficult for development to develop with searches and things like that. So, some homegrown, some commercial solutions as well can just make the masking fairly poor. So, diversity is almost have considered. Now, here's another one. Masking is almost never kept up to date. What you find is that once it's done, then it's forgotten about. But the problem is you're constantly adding in new releases. So as part of your release cycle, you need to make sure that any new tables, any new fields, any new JSON elements, etc., are coming through, and those then have been considered for masking. The masking has been put in, it's been tested, it's been verified, and the data owner has signed off that this is good. So it's almost never kept up to date. And as discussed, it's a slow and disruptive process. And once again, it's a very risky way to run an IT department. So let's move along. Homegrown features are really not good enough. Set up with the best intentions, but drift. You may have some really good developers set it up, but then someone has to maintain it. They might have to change the code, etc. So, and also they don't really have enough of the sort of features out there. Some masking tools are just insanely expensive, which is kind of mad. There's no reason. You probably end up with probably about 50 core algorithms that should be able to handle that, and the cost to develop those is relatively straightforward. They are billed as black box magic, and as I kind of said, it kind of gets the CIO off the hook. The data is passed into this amazing masking engine, which is kind of hidden away. Fairly inscrutable technicians will work on it, and then magically the data comes out, and that's it. They've just paid some money, the problem's gone away. You need oodles of masking features, lots of routines, hashing. You need to worry about avoiding clashes if you use hashing to make sure that you don't end up with 1 becomes 2, 2 becomes 7, and 3 becomes 2. Those types of things are deeply technical, deeply boring, but they do occur. Deterministic, and as we talked about cross-technology, you're masking data consistently across the different technologies. Same with ERPs, mainframes, messages, and files. You have no idea where the data is coming in. You could just have an app, and that app is creating a series of messages which are then flying across into your systems, and you've taken some of those files. But what you can do is mask those files in flight and just move them on into the system, but as long as you're using the same masking algorithms. Now, the other thing which is really important is that how do you know what data needs to be masked? And the reality is data scanning. Now, lots of the tools out there, not ours, basically just looks at the metadata. It just looks at the names of the columns in the catalog, and and it says, "Oh, right, fine. That looks like it's got a name which is a person or account or something like that." And there's never really any deep scanning of data. So you do need to actually go pretty deep with your scanning, looking for data, especially with things like flex fields. You'll have things like, vsam files on the mainframe. There's all sorts of things going on. You don't really have this continuous scanning, as I talked about, which is this idea of having scanning continuously to see how people use the system in different ways. Therefore, data suddenly starts moving out of where you thought it was going to be, and you'll end up with things being kept in notes, for example, where account numbers might be changed, or notes about account numbers might be within that as well. Um, you know, so there's deep data scanning does not exist, and it really fundamental to that. And there's very little audit and notification of potential PII. So what you need to do is, as the scanning is going on, you're getting notified. Oh, we've spotted that this data is, we haven't seen this data before, and it looks like it's PII and it's in this field. What do you want to do about it? And you say, no, that's fine. Um, you know, on this date, I've agreed this is fine. Or you basically say, well, this needs to be dealt with. Okay, so there's all these issues. So let's get on to some new ways of thinking about solving some of these problems. So, the reality is there is a need to rethink the approaches to data provisioning across the organization. Now, AI can massively help accelerate tasks that simply weren't possible before. So this AI is great. It pays off lots of technical debt for you. It can plow through. It can do lots of the boring stuff. It can say, "Does this look right?" You say, "Yep, great," or tweak it a little bit, and on you go. So that now does make a big difference in that you can pay off a lot of the legacy debt. Now, that legacy debt actually contains a lot of the information you're going to have to deal with when it comes to provisioning data. So that's really helpful. You need to understand the different types of technologies that are available for the stacks that you're dealing with. If you're using something like Oracle or SQL Server or some of the cloud versions, there's lots and lots of really cool tools within those databases themselves. So let's start thinking about using them. You know, um, so great, you start using them, and then suddenly you've got to fill in 1,700 change requests and 45 documents as to why you want to do this and what's the benefit to the end customer. And of course, the answer is none. Um, so this also comes to think this idea of restructuring your budget to include a central team, bring together a small team to build out the new approaches. And I think this is pretty much the fundamental point of a lot of the stuff in this webinar, that you are going to have to put together some kind of team to be able to solve some of these problems. Education and agreement will be needed, but beacon teams need to drive. This is typical. We do a lot of stuff with synthetic data and modeling, and there are beacon teams that just absolutely love it, instantly adopt it, can see the benefits. Great, they're off and running. Then there's the medium teams, and you have to kind of just educate them and kind of slowly hold their hands and get them through. And then you get some lag out teams who just will not, we dump it into a spreadsheet, and then we've got several macros and spend 4 days working it out, and then and then we do what we've always done. So you do need to think about how you're going to change the way the organization operates. I would strongly suggest that team members need to be trained in the concepts of data management and data. If you can get new hires to spend maybe a couple of months in the data management team before they move out into the organization, they will absolutely be more productive and more cooperative and more understanding of how good, accurate, timely data can significantly improve the delivery of systems. Now, the trouble is, you are where you are, and that might not be ideal. And generally, the idea is, with like most things, is to supplement what you already have with new approaches, and gradually you can do kind of a full switch over and say, well, actually, we're just going to not bother with that. Dev 1 environment anymore. It's so out of date. We've got our Dev 2s and Dev 3s are being updated every day with new transactions. So let's just use those. Now, let's just talk about the, stage one. You need to kind of establish an environment team. Now, this is made up. So within that, you would have environment management, DBAs, security and risk team, data technologists. These are, didn't have to be super duper technologists, but certainly people who can put together, Python scripts, can operate tools, etc., can understand their way around databases and database technologies. IT management absolutely need to be brought into this. They're the ones that are actually going to see the long-term benefit, medium and long-term benefits of this, but they then absolutely need to fight up and fight down to be able to support this team that you're creating. Quality management, QA teams, tend to uh, they tend to be a little bit, I'm not going to say powerless, but sometimes they're, because of the relentless drive of development, it's very difficult for them to kind of intercept and say, well, actually, this is a really bad way of doing things, and you should think about doing it the other way. And it will always be, yeah, later. So it's a tough gig, and unless you've got a very strong support from IT management, it could be tricky for the quality management team to drive the change that they really want. Development teams, within the development teams, they'll have lots of ideas, and they will actually, they'll probably have a ton of technology that they've already built as well, which would be useful to be used by the data technologist. The BI teams are actually pretty good in that they actually have probably one of the few places in the organization that has spent the time looking across the data, across the entire organization. Whether that back in the day it was kind of data mining and data decision making. Now it's of course driving the AI teams, etc. And those are the kind of AI LLM strategists. So team must be flexible, problem solving focused. Team members must have the support of the local management and overall IT management. Now, with everything, like everything, look for small successes, prove something, enhance it, move on. So you work out a way of getting, 5% of your production orders out of production, masked and applied daily into your development environment. Brilliant. It's the whole project's taken 3 months. The amount of effort's about 3 weeks work. Most of it was just getting permissions. Once that's up and running, then you start showing that around and you move on to kind of more interesting things. So there's all sorts of ways to think about it. Create small reusable components to build a flexible solution. If I have time, I'll just kind of quickly show you a small demo where we've kind of put together the various different bits to be able to pull out small subsets of data into development environments. Next one, the technology. What tools do you have? How are they maintained? And are they cross-tech stacks? There's lots of tools out there. Obviously we provide a full set of tools, but again, we would generally sit on top of your tools as well, because you may well already have some interesting stuff out there to do various, in effect, data management tasks. Look at the current process in detail. Good place is to actually spend some time and look at this, 21-day data refresh, and actually look at where is the time spent. What technology is actually doing the process, and really have a good look at it to kind of fully understand it and where it can be. Do we just start again, or are there various bits in there which could be useful or just made better, etc. You also need to build up kind of an ROI audit where problems and costs are occurring in your development. If you've got bugs occurring in production, that's costs a fortune. If they show up in QA1 and QA2, you've got to go back 3 or 4 stages, so they're much more late to the party. They cost more to repair. The ability to recreate a bug in development. How long does that take? It might take a week to set it up by hand, and then you think you fixed it and you haven't fixed it. And the reality is what you really want to do is pull out the data associated with the bug, mask it, and just bring that in with minimum disruption. And if you think about that, if you can audit and come up with an actual cost, then suddenly this idea of spending some money, having a budget on the team is pretty key to be able to make that actually kind of work. new and old available technologies. There's all sorts of tech out there to help you with that. So spending a little time looking at the tools where they would fit, and again, this is fantastic if everyone goes and does their research and then they actually sit in front of a whiteboard and do the good old-fashioned brainstorming to try and kind of sort this stuff out. Um, Look at reusing existing production technology. If you're dealing with ERPs, for example, a lot of you will generally have already built a whole series of processes to populate data into your ERPs. For example, you might have a customer intake file which is used when your suppliers provide you with a list of new customers, or sorry, your agents. Now that's a really decent piece of technology which you can use to populate development environments. All you're really doing is taking some of the production data, masking it, some of them, not all of it, and putting it into those environments to push them down into the lower environments. So you really need to kind of understand, all of the different existing production ready technology which can be repurposed. Um, Look at using internal code. You'll also have lots and lots of code sitting around inside your Git repositories, which does all sorts of things. And you've got to really kind of think about how could you use those test automation. You may well already have loads of test automation scripts which actually populate information, into systems. And if you just parameterize that up, you can use that to actually push the data into development environments as well. So there's lots of stuff that you can use that already exists. So you don't really have to build too much, hopefully, together. Market tools, some open source, which is fine. Open source projects tend to get away from themselves sometimes. Um, and then there's the best of breed commercial as well, which can help you, with some of the components to build this strategy. But the reality is you are going to need some new tech. You'd be lucky to get away with just kind of re-architecting the stuff you already got. Must have AI accelerators, subsetting, pulling out small sets of data is crucial. Cloning and reassigning queues is essential. So that is, now the reality is if you pull out, let's just pull out a particular customer with all of its customers' orders, with all of its orders, items, suppliers, products, shipments, fulfillments, etc. Pulling that out and putting it into the development environment where it already exists, that actual customer with, it already exists, then you're kind of into like a whole kind of reconciliation process. So what it's sometimes easier to do is just pull out that customer, assign it a new customer ID and a customer name. You could even call it, the original name dash clone, and build a whole set of orders, items, fulfillments, etc. And what you're doing is pulling out a clean set of it, and that's this idea of reassigning keys. So we have a synthetic data tool, and one of the most common places to start is actually to use cloning, where you're actually pulling out maybe 20, 30, 40 tables of data, maybe anywhere between sort of 100 to a couple of thousand rows of data, but as part of that you end up with the data within the environment. Now the advantage of this as well is that chances are in your lower environments you'll have additional columns. And when you do this process, you can then just add in any additional values to those columns, otherwise the data would not normally load. So the synthetic data generator, very useful. Again, I think we've done some webinars on that, but certainly have a look at that. Now, the other one, which is pretty crucial, is federated matching of data across technologies. Now, the reason for this is to do with integration testing. Now, if you're trying to pull data down from production and you're going to put it into an environment, now that data, there's a good chance that a bunch of it refers to data in other systems, broker codes, payment plans, etc. Now, so what you need to do is when you load that data up, you need to make sure that the ancillary systems actually match. Now, the way that, as I talked about ragged edges before, is that if you put the data in and later on you try and load it and it falls over, then you try and clean up afterwards, it's a bit mad. So it's better to create a federated view. So we have a federated data engine. We use CData extensively, which has connectors into most of the ERPs and technologies, and we can create a federated view. So when we load the data up and say, right, just when you're loading up this payment code, does it exist? Great, carry on. If it doesn't, let's assign it to another payment code which matches directly within the system. So this ability to create these federated views of data across your integration system is pretty fundamental. Automation of data creation using flat files, API messages, and directly into databases. That's kind of the new world order. I've got a slide on that in a minute, so I'll talk about that. Reconciling structures, differences must be built in, as I talked about. So, if new columns have been added in, you should very quickly be able to put in a default value into those as well, so that the data actually does make sense. The other one is tracking your data requests. Auditing who's requested which data is a very useful way to understand um, how people are getting along, what kind of benefits you're getting, where you should put your effort. If you kind of understand certain teams are requesting lots of this type of data, then you really do need to support them. But if you don't have a tracking of who's doing what, then it's all a bit of guesswork. The other thing is that all of these processes need to be pulled into, some process automation tool or RPA tool, so that you can basically assemble them together to be able to solve your problems. This idea of daily data hydration is really good. I think it was the Bank of India we went to once back in the day, and the way they used daily data hydration they had about 10 people who simulated production transactions. They had like a mini fake bank, so their entire development environment was made up of people actually pretending to be to work in the bank to pass through transactions, etc. And that actually was an interesting way of doing it. It was very effective because they had absolutely no production data in their development environments at all, which was brilliant. But nowadays, you could use basically logging to pull out the transactions, mask the data, and push them on and kind of simulate the data, and supplement that with some synthetic data to push in to make sure that you had a good spread of data. We did some work for one of the big central banks, and we created 10,000 messages every day, every 10,000 payment messages every day, to simulate current activity. Um, so first things first, building out the corporate dictionary. Um, AI is very good for this, and obviously the scanning, um, you know, being able to actually understand what you have. And that is not just databases, it's the files, the messages, the payloads, all of that stuff, is really fundamental to being able to kind of understand where you are, what you've got, version management, etc. So this building the corporate dictionary is kind of pretty crucial to be able to kind of uh, have a good understanding of what you need to do. So understand your tables, reference, metadata rules, flex tables, temporary tables, archive tables, transactional tables, parent entities. Now, even within parent entities, you have business core objects and then you have business attributes. So if you think about businesses, people will generally talk in, maybe they have like 50 common business terms that they refer to. And with each one of those business terms, you have um, distinct, a customer, what is a customer? A supplier, what is a supplier? What is an order? All of those things are kind of core. So being able to understand those is kind of really fundamental. How are they joined and linked together, both as core attributes, but also in terms of foreign keys, which actually there aren't very many, but more involved with the kind of the meta relationships or soft relationships, as we call them. Then there's this aggregation and audit tables, which happen at the end of the month, your GL balances, all of those types of things that really come in understanding your tables. And then you need to kind of understand your use cases. Within that, you've got metadata rules and flex tables, you've got transactional tables, all of these different things. What are they used for? When we're actually thinking about the use cases that we're going to be testing, we can lose anything in blue. We're not really interested in it. Um, you know, and for the transactional tables, we probably only need the last 6 months. You know, um, and once you've got that, you've pretty much got yourself a much smaller subset of data that you can then pull into your development environments, etc. So the approach that we recommend is you have your production data, and what you'll do is you'll basically have the ability to extract small amounts of master data on demand, time stamped and version controlled. Okay, so you define your subsets where you're pulling out certain core um, types of data. Maybe it's just it could be, as I say, just the data based on the last 6 months of data, or it could be specific suppliers or accounts, or it could be data associated with a particular bug, and all of those get pulled out, and those then end up down in a catalog of data sitting sitting uh, sitting inside um, the staging area. And that staging area is close enough to your development environments. It's clean data, it's been masked. You've actually spent some time doing a very good job on masking it. And they're sitting there ready to be loaded in. Now, this is where you get into the key assignment or the cloning. And that really allows you to create multiple copies of data, and you might want to have several copies of that. You can push the data in directly with DB inserts and updates. You can put in flat files, or I would say nowadays, if you're dealing with something like an ERP, what you generally are going to do is you're going to be constructing payloads, which are then going to be pushed in via APIs. And out of that, you basically do some, we've got some pretty neat transformation, which allows us to pull out the raw boring data sitting in the database and just populate it into these APIs and push that into the development environments. Now you can obviously, as I mentioned, use automation as well. That could be sometimes API automation, but it could be front-end automation. But all of these give you this kind of powerful ability to be able to do that. I'm just going to quickly pop off and just run a little demo. Now, this is an example of a pipeline. And what we're doing here is we're pulling data into a subset database. Now the subset database is, think of it as the area close to your production environment. Now, if we look at the subset that we're going to do, what we've done is we've pulled out a certain subset of data, which is to do with, in this particular case, we're just dealing with the sales. We're interested in the products, the customers, the orders, the items, and that gives us our subset definition. And when we run this, we're basically, we've got a choice. We can use daily increment or specific products. The daily increment is basically going to pull in the increment from the last time that we were doing it. So we're truncating, we're running our subset. Once we do the subset, then we've gone in and we're doing our masking. And we're pulling out, in this case, maybe, just maybe 1,000 or so rows of data, 1,000 or so products which have come in, which have been created in the day, and those then come over daily into our at the beginning of the day. That ends up in our staging area. We populate the staging area. Now, normally these are slightly separate because you would actually be moving the data out of the production environment into your development. In this case, I've tied the two together because I have access to both systems. Now, at the end of it, what we've also done is we've come in and said, well, let's have a look at, in this case, to load the data, we've basically, just go off, and we've basically got to create a JSON structure. That JSON structure has basically, that JSON structure will then be used to push the data into the development environments using an API, which is this one over here. Okay, so that's really what's happening down the bottom there, like that. Okay, so this idea of modularizing things, creating small components which are then allow you to build up these kind of like quite neat and flexible little systems. And sorry, just go back to, let's go back and maybe load the data from staging. And what you've got a choice here is choose the staging region. So in this case, we've got some specific products. I want to do a direct load, or I want to clone it. And when I clone it, how many do I want? And as people have pulled down these subsets of data, they've basically given them names. I've just been working on a couple of different sets of data that I need to pull in. And then that data is then available as kind of a shopping cart to be able to push into the development environments on demand. So in effect, you end up with kind of a faster and more nimble approach, doesn't disrupt existing data. Bug data can be easily recreated easily. Rare data can be exploded. Long chain histories are particularly problematic. And having lots of them makes life a lot easier when you're trying to do quite complicated development and testing. The other one is data can be aged easily. So we may have a set huge staging area, but it might be slightly out of date. And when you actually populate the data, you can just say, well, just bring all the dates up by the minimum add from the minimum date to the number of days, and actually make it sort of real data. New columns can be populated automatically. So in other words, this ability, kind of a flexible architecture, is really, just gives you the best of all worlds. You can carry on working, you can create your own data in the environment, but you can pull out data from pretty much any environment you want and push it in a really structured way. Um, and as I said, daily data can be added to development. So yeah, a good way is to just have a cron job running, which just populates maybe 1,000 new orders every day, so that all of your roll ups and end of day order processes can be tested as well. So recommendation: investigate, interview, build a consensus, prototype, put together a small team to build out the types of technology that's going to work for you. Create a tiger team to get it done, and that's getting the people from the DBAs. The DBAs back in the day used to be really, really creative. They were the guys that actually came up with lots of these ideas and sort of really helped the development teams. I'm not quite. I mean, you meet DBAs, they know all about this tech. They really do. But they're so far removed from the development teams, they never really get a chance to kind of show off their skills, I suppose. Be pragmatic. Let's be realistic about this. You've already got a bit of code to do it. Let's just use it. The solutions will evolve. The reality is, if you put together a team, you should be seeing benefits inside 2 months, and those benefits, would rapidly accelerate across the organization. You need to set the standards and rules for the teams in terms of how they request these new subsets, and what type of data they need, what type of integration testing they're going to be performing, and to do that, you need to set standards and rules to be able to help them. And your IT will improve pretty much across the board. You'll be able to develop faster, leaner, meaner, much more reactive. And I think that it's kind of how we've ended up in this sort of massive mask it, copy it, mask it, copy it, load it. Is kind of a bit mad, to be honest. So, you guys, Sophia, you still there? Harry, you still there?
Yeah, I'm still here.
Yeah. Okay. Sorry, I've just run on a bit. I'm conscious of time here. I think we've bumped into it. So I'm sorry. I'm gonna cut you off, Harry, and your contribution is going to be fairly light this one. So so basically, one of the things we'd like to offer is just get in touch. Get in touch with me or Harry, and we'll just book in a session. And what we'd like to do, first of all, we'll learn from you. So there's something in it for us, even with just an hour chat or something like that, just to kind of understand what you're up to. We'll kind of tell you best practices that we've seen with some companies out there, what they, in similar industries that have been able to make some successes. And then also, once we've done that, we can help you out by giving you some material, which you're going to have to do some evangelizing, you're going to have to do some internal selling, you have to calculate some ROIs, etc. We've got lots of information which can help you do that. So I think, if there's anything that comes out of this, I've covered a lot. We'll obviously send out the material to you and the recordings, which will hopefully you can use as an internal selling tool. But beyond that, feel free to get in touch, and we'll set up these workshops, and hopefully just kind of get you moving along this road. Okay, so that's it. Thank you very much. We didn't really have time for questions. If there were any questions, we'll send out written responses to the individuals that have asked them. Okay. Thanks, everyone.